Now for this question, I'm going to be talking about this type of system, but the key difference is now there's friction. So it says a 12 kilogram box rests on a horizontal surface with a coefficient of kinetic friction of 0.25. The 12 kilogram box is attached to an 8 kilogram box through a massless rope. What is the acceleration? What is the tension? So we're looking for acceleration and tension again. And this problem's gonna be very similar to the last problem I did when there wasn't friction, but there's a key difference. So now, looking at my free body diagram in the x direction for this, since it's moving in the x direction, I have tension this way, and I have the force of friction now this way. So if I want to know the sum of the force in the x direction, it's going to be tension minus friction force is equal to m1ax, because mass 1 is moving in the x direction. And remember, I have to solve this one for tension. So tension is equal to m1ax plus the friction force. One more step before I can be done with this equation. We don't know friction force, but we do know the coefficient of friction. And we know that the friction force is equal to the coefficient of friction times the normal force. So with that being said, what I can do is replace friction force with this. So tension is equal to m1ax plus coefficient of friction times the normal force. Likewise, let me do my free body diagram for object 2. So now it's going to be the force of gravity and tension. So my sum of the forces, or my net force, in the y direction is going to be tension minus force of gravity is equal to m2 ay. But remember, since it's moving down, it's going to be negative right here. So simplifying this, I have tension is going to be equal to negative m2 ay plus fg. So I have two equations for tension. The first is going to be m1ax plus coefficient of friction times normal force. And then the second one is going to be negative m2 ay plus the force of gravity for the second object. So I can equate these two together. So it'll be m1 ax plus coefficient of friction times normal force is equal to negative m2 ay plus the force of gravity for the second object. And we know that the acceleration is the same, so we can just change ax and ay to a. And if we are solving for acceleration, we need to get like terms on the both sides. So everything with a on one side of the equation. So m1a plus m2a is equal to, and I'm going to move this term to the other side. So minus coefficient of friction times normal force plus fg2. Factor out my a, and I'm going to get m1 plus m2 is equal to the negative coefficient of friction times the normal force plus fg2. Now the rest is simple, just divide by the sum of the masses. So acceleration is equal to negative mu Fn plus Fg2 divided by m1 plus m2. So if I actually want to solve for this, I need to know what my normal force is. And remember, I can find my normal force because in the y direction up there, so this is the free body diagram in the y direction for the first box. So whatever my force of gravity is for this box, that's going to be my normal force too, because it's in equilibrium in the y direction. So my Fg equals mg, which is 12 times 9.8, which is 117.6. Since my gravity is 117.6, my normal force is 117.6. So normal force is 117.6. So if I want to solve for my acceleration, it's going to be negative, remember the coefficient of friction was 0.25. So negative 0.25 times 117.6 plus my force of gravity for the second object. So my force of gravity for this object is going to be Fg equals mg, which is 8 times 9.8, which is 78.4 plus 78.4 divided by 12 plus 8, which is the sum of the two masses. So my acceleration is going to be oops, sorry, 2.45 meters per second squared. Oops, sorry, I put that in the wrong box. Now, I have to solve for my tension. And remember, I can use either one of those two equations. So I'm going to use the first one. So tension is equal to this equation. So it's going to be 12 times acceleration, which was 2.45, plus 0.25 times 117.6. $58.8 newtons. Now, if I use the second equation, which I'm going to show, what I'm going to get is negative 8 times acceleration 2.45 plus Fg2 was 78.4. So negative 8 times 2.45 plus 78.4. 58.8. So my tension is still the same. So this is how you do a Fletcher's trolley problem that has friction. So when you have a mass on a surface and then one hanging, then the only difference is when you do your sum of forces in the x direction, it's now you have friction. So it's going to change it up a little bit. I hope this video was helpful.